Jonathan, this one in school you already finished already. Next chapter, energy.
So lost in it.
You everything also lost lah. What are you not lost in?
She keep talking, but she never explain.
I also keep talking.
No, but she never explain, she just go fast.
Go fast. Okay, come. Energy, this chapter. Okay, so you definitely heard of energy before lah. You can tell me there are different types of energy, right? So if I'm running or walking, what kind of energy is that called? Kinetic energy, right? Okay, so now you see for your 2024 now. Last year onwards, they changed this chapter a little bit. So they call things like kinetic energy. They just change the name okay, to call it what? Kinetic store. Okay, the stored energy that is called kinetic. But if you were to use the same word kinetic energy, nothing wrong but they just use this word more, kinetic store. So you will see this very often. Okay, kinetic store. Okay, so first thing we talk about the principle of conservation of energy. This one I think you're familiar with already lah. Can you tell me what is it? I think you should know. States that energy cannot be created or destroyed.
Can only be
Converted from one form to another form. But now in this chapter they use the word transferred. Okay, transferred from one form to another form. So you will see the kinetic store is being transferred to become chemical potential store, for example. Okay, right. Okay, so the next sentence, the total energy of an isolated system is, does it change, increase or decrease, or remains constant? Remains constant. What does that mean? Okay, that means to say if I have a water bottle there full of hot water, the energy here should remain constant. But in actual fact, does it ever remain constant? It loses energy to the surroundings, right? But if it's isolated by itself, it will forever have the same amount of energy. But that's not going to happen. Okay? Okay. Now, you look at this, the different types of store you have. Kinetic store or kinetic energy. You just have to remember a few things. Okay? Kinetic energy due to motion. Okay, depends on speed. Always remember, depends on speed. Gravitational potential store. So if I say kinetic store depends on speed, gravitational potential store depends on what?
Height and the
height. The height. Yeah.
That's all.
Yeah. Okay. Mainly due to the height. Okay, so it's height. Okay, then chemical potential store, energy. Okay. In food, okay, batteries, all those kind of stuff. Nuclear store, nuclear energy, right? Nuclear reactors, all this kind of stuff. Okay, Singapore got nuclear reactor. Got next time, I think. When I'm dead already, you probably have a nuclear reactor in Singapore. What?
Later they will have a meltdown because of it.
They melt down, that's it. Jonathan, you are the nuclear reactor.
I fly already.
You are the operator of the nuclear reactor. Then we might have a meltdown. Forgot to press the button. That's it. Okay? Okay, now what is this thing? The next one, internal store. Internal store, just remember, is thermal energy. Okay, heat. Okay, so there will be a rise in the internal store. The amount of thermal energy increases. Okay? So that all of us are giving out, all of us have internal store, right? We constantly give out heat, if not we won't be alive. Okay, so even ice also have internal store, but very little. And then you got other things called elastic potential store, rubber band, all this. Okay, so these are the various store of various energy which you all know. Jonathan, do you know that there are different types of energy transfer? So now in this chapter, you need to know how is the energy being transferred. Okay, so for example, this one. So I take the object, hold it up in the air. This is gravitational potential store. I drop it. This calculator gains speed, going faster and faster and faster. So it is the gravitational potential store being converted to a kinetic store. Okay, then you must know, or you supposed to know now in this chapter, this energy is transferred by what type of, what means? Mechanically by a force over a distance. Okay, meaning what? So when it drop, what is pulling it down? Gravity, right? So gravity is pulling down gravity is the one that's pulling it down over a distance. So the transfer is number one. Okay, then there are others heating due to temperature difference. Okay, all this you will see some example later. Propagation of waves. Now this one you haven't learned yet. Electromagnetic waves like what? What kind of electromagnetic waves do you know? You know some, definitely you know some. So for example, you go out in the sun, you just stand out in the sun. There's a danger you get what? Your skin become dark, sunburn because of what? What kind of, they say it's not good for you. You get too much
radiation.
What kind of radiation is it called?
Can't remember.
Do you know? Yes, ultraviolet. Okay, so EM's waves there are 7 members. Okay, one of them is ultraviolet waves. Okay, that one can cause skin cancer. Then you feel very hot. Why? Because the sun gives out something. What is this? You've heard before. Infrared, right? Okay, infrared waves. Okay, so infrared waves. So you stand in the sun, extremely hot day, like today, like that.
Like, for example, like
the sun
there's
gives
no
out.
ozone layer.
The what?
There's no ozone layer, then there's more ultraviolet rays, right?
Yeah, correct.
Oh.
So and then the sun gives out infrared.
And
We
more
also
skin
give out
cancer.
infrared, right?
Oh,
Okay,
that's why Australia so much skin cancer.
because a lot of sun. Okay. Okay, next one, propagation of waves, mechanical, like for example what, sound waves. Okay, so and then the last one, electrically by electric current. Okay, so these are the methods of energy transfer. Okay, I show you how we use all this. Okay, you look next page. Okay, you look at the next page. For example, this one. Okay, the before. Okay, hydroelectric power station. You don't know what's hydroelectric power station, right? You don't know,
All of them.
The dam. Singapore got or Jordan?
No.
You sure?
Yeah.
I thought Marina Bay got.
Oh yeah, no.
No, right? Because
You stay higher up.
you need something really high up, right?
Then it goes down.
Correct. Okay, so it needs to be very high in a dam. Okay, what is the end product you get for a hydroelectric power station?
Electricity.
Electricity, correct. So you want to produce electrical energy at the end, right? So something like that. So over here at the top, very commonsensical. What kind of energy?
Gravitational potential energy.
Gravitational potential store lah, right?
And it flows down. And it spins something and then generate electricity.
Very good. You got it. So over here is what? When it reaches down at the bottom, all the GPE become kinetic store, right? Or kinetic energy. Then Jonathan say go and spin something here. What's the thing that spins? What is it called?
Some like turbines.
The turbine, right? So the turbine, what kind of energy? As it moves, anything that is moved is kinetic store or mechanical. Okay, so kinetic energy. Then it will start to generate electrical energy. Alright? So in the past it's very easy. You just have to know how is one form transferred to another form. Okay? Now Okay, you have to write things out like that. It's the before. Okay, the water has gravitational potential store. Okay. Again, if you use the word energy, I don't think the teacher will mark you wrong. Okay. You will not be marked wrong. It's the same thing, right? You cannot say. I don't think they are so inflexible, okay. So they got gravitational potential store at the top. Then energy transfer occurs mechanically. Why? Because gravity is pulling it down over a distance. The water will gain what kind of energy? Kinetic store. Jordan writing on. Okay, so you see what have you done here? This is the method of transfer which you have written. You see when your teacher teach, okay, so far I see all the schools, they are not so like, so insistent, you must write like that, okay. So it's still quite okay. But the before, gravitational potential, then after that method of transfer is the mechanically by a force. Then after that become kinetic store. Okay, then after that the water transfers energy mechanically as a force causes the turbines to turn, and the turbines gain obviously kinetic store like you said, and then as a result it generates electricity. Okay, so that is the process. Now besides describing this way, Jonathan, you all learn the what diagram is it called?
No diagram.
God lah, you everything don't know one. What is this? Have you seen this before?
Oh, the LOL thing.
Correct. At least you got pay attention. The LOL. They call it the LOL diagram. Okay.
Oh, the energy loss that you compare to the other graph. I forgot it.
What does O stand for?
No idea.
The object. What's the object in this case?
Water.
So this is the water, right? Okay? So the O is the object. So L, this first L, this is, what is this? So here, this is like the before. The before, let's say, they draw like that. Let's say I draw that's 1, 2, 3, 4, 5, 6. 6 units of gravitational potential store. Right? Okay? 6 units of gravitational potential store. Then after that, okay, the water, the O, what's the method of transfer? Okay, this one we already write already. Mechanically over here. I'm not going to write again. Okay, by gravity. Okay, now does all the gravitational potential store become electricity in the end? Does it all become electricity?
No.
What does some become?
Can't it be like heat?
Heat, right?
Yeah.
Because of what? Why? Why do you have heat? You're correct for heat.
Evaporation.
Heat, evaporation, no lah. Why got heat? Because of what? When the water is rushing down the friction where? A lot of places got friction like where? You just look at it. Huh? The what? Where do you have friction?
Yeah, flowing down.
When it's flowing down the pipe, right? That's one. Where else? The turbine also got friction, right? So this friction is not an energy, but when water runs through the pipe with friction, kinetic energy is to overcome the friction, so it's being converted to heat, thermal or now what we call internal store internal store of surrounding. Not only that you ever go to a dam, not only heat, there's a lot of sound as well, right? So not everything is becoming electrical, right? You're going to lose some energy in the end to other things.
What's so bad about building a dam?
Huh? What's so bad about building a dam? Okay. So not all the gravitational store become electrical in the end. So over here, I just say let's say for example, 2 units lost to internal store of surroundings. Okay, so what does this mean? That means 2 units of energy become thermal energy lost to the surroundings, correct? Because of friction, okay, in the pipes. So over here in the end is our electrical energy or electrical store. How many units should I draw? I started with 6, 2 was
4.
lost. Here must be
4.
4, correct. Okay, so that's the idea of the LOL diagram lah. Okay, got it? So it's the before, the after, and O is the object. What is the object? Okay, and then anything lost to surroundings. Okay, so that's last time 2 years ago they don't have to study like that. Now you all have to study like that. Does it make it more interesting?
Yeah, so even the Sec 4s don't have to learn this.
The current Sec 4s, yes, you started with them. You are the second batch. And which of course this guy is dying.
I should take combine.
You should have taken combine. And can convert end of the year.
Cannot.
Next one. Okay. Energy system in the eardrums of a student in a quiet room before and after the cymbals are hit. You know what's the cymbals, right?
Yeah.
What?
To load plates. The metal plate.
The plates. Okay. So the eardrum has what kind of energy?
Sound. Heat.
Eardrum. Heat.
Heat. Because your
Eardrum
body heat.
in cymbals.
Your body heat. That's not always sense. Body heat.
Jordan. The eardrum has no kinetic store.
What?
Before the cymbals are hit. You are in a perfectly quiet room, which is of course quite impossible. So your eardrums are not
Because your
vibrating.
eardrum vibrates. I forgot
Right,
about
so
that.
it's not vibrating means no kinetic store. Perfectly quiet. So the before, nothing to draw. O, what's O? So here,
Sound.
symbol, the symbols of the ear, the object, the eardrum. Okay. Then when the symbols are hit, energy is transferred by which one? Which of the 5 ways? Obviously, which one? 1, 2, 3, or 4? Smash the symbols. So 1, 2, 3, 4, 5. Which one?
It shouldn't be like internal store.
When you hit the symbols, transfer, method of transfer. How is energy transferred when you hit the symbols to the ear?
Like kinetic store. Sound. Mechanical. Wait, should know.
How does it go to your eardrum? Sound waves, right?
Yeah.
So it's mechanical store, okay, propagation of waves. Okay, so it's transferred by propagation of sound waves. Okay, propagation of sound waves. Okay, as a result, what happens? The eardrum has a gain in kinetic store. Okay, so the before, diagram before, nothing. Diagram after, okay lah, let's just say 4 units of what? Kinetic store. Okay, so the method of transfer, propagation of sound waves. So you just understand how the LOL diagram works. Next, ice cream. Okay, ice cream is what kind of energy?
Ice cream. Heat.
What do you call heat? Thermal. Okay, thermal store, otherwise known as what?
Internal.
Internal store. internal store. Yeah, it's cold but it still has internal store. Then as a result, as it's placed in the sun, energy is transferred by which one?
Heating. Ultraviolet waves. Yup.
Which one is responsible for
Infrared.
heat? Infrared. So propagation of infrared waves. Okay. As a result, the ice cream gains internal store. Okay. So very simple. LOL diagram before maybe 1 unit. O, what's the O, Shahir? The sun, the ice cream.
The ice cream.
The ice cream, yes. Okay, then after that, let's say 4 units of thermal energy transferred. So in the end, after how many units should I draw? How many units should I draw? After? Start with 1, added 4, so in the end?
Like 5.
5.
Will they ask you to draw this out?
Possible. You see when your teacher teaches whether they ask you to draw it out, yes. But it's quite commonsensical lah. Huh? Whatever you this plus this must give you that. Okay? Did your teacher ask you to draw this out?
He just covered it one lesson, I don't know how.
And you never bother to do.
I just said that I'm so lost.
Say that,
I just started watching YouTube.
Or you watch YouTube, then you dare to use a phone in your class.
I didn't use a phone.
Then
So I
use your iPad, worse. Then didn't catch you.
no.
Not yet.
Didn't just gambling.
Still gambling.
He just watched poker music.
Okay, come. Next one.
Sleep already.
Okay, you all fill up the next one yourself. So then 4. Wait, do a few more, then we stop already.
Has energy in its internal store. Energy is transferred by conduction.
Not conduction lah. Look at the 5 methods.
Heating.
Which one is it?
Shouldn't be heating.
Heating due to what?
Temperature distance.
Temperature difference, right? Because the frying pan and the egg will have a temperature difference, right? Okay. Okay. So this one, the egg is in its internal store. Okay, then after that, energy is transferred by heating due to temperature difference. As a result, the egg gains internal store. So straightforward. However, in real life, there is also increase in something of the surroundings.
Temperature.
Internal store of surroundings, right? You're going to have heat loss to the surroundings, right? Not everything goes to the egg. So heat loss to surroundings, or otherwise known internal store of surroundings, as energy is transferred by energy difference between the egg or the frying pan and the surroundings of the and the surroundings. Okay, that's by infrared waves as well. So by conservation of energy, the total energy must remain a constant. Okay. Okay, come next.
Like, don't you say that like some of it might
Okay, so the first blank transferred by what? Mechanically. By a force over a distance. Then this is kinetic store. And the swimmer, as she begins to move, in reality there's an increase in internal store of the swimmer. Okay, and some energy is also transferred by infrared waves to the surroundings due to work done against. Due to work done against. Due to work done against. Gravity. You swim against gravity. Friction, right? Water resistance. Okay, we call it water resistance.
Wait, so will there be like questions where like they'll show you a diagram, then they will ask you to draw like the forces acting upon you?
I see, it's very hot.
Okay.
It's very hot outside.
Ask you a diagram drawing what?
Like forces, so that it can help you like answer the question.
Draw forces. There's under chapter of forces. Possible, can. Right? Swimming. If you ask you swimmer, for example, swimming in water, what are the forces acting on the person as they swim? Also can, right? Right? Then the usual, you tell me what is it?
Is the other one thermal energy?
Okay, we sidetrack a while. There's water resistance. Right? Water resistance. What else?
Increase of energy in the
Wait, Jonathan. Now we talk about forces. What else? You're pushing forward, right? So there's a what? There must be a forward force, right? Forward force, like that, possible, can ask. And then, of course, there's the weight, Okay? So it is possible to ask you such a question. Yeah, okay, so back to the question. So, due to work done against water resistance, and there is an increase in the energy of the what store?
internal store.
Internal store of the surroundings. Okay? So quite commonsensical, right? Okay, come, last one. Let's do the pendulum one. Okay, you all know pendulum, swinging from A to C to E. Okay, common sense. Fill this up. Common sense. Easy. Maximum potential energy occurs where?
At A.
Potential energy, GPA. A only. Jonathan, happily drawing ice cream.
Sugar energy. Swing it at A.
Only A? You swinging A to C to E.
At E as well.
At E as well, right? Yes. How do you know? How do you judge where is the maximum GPE?
Highest point.
Highest point. Because GPE always depends on height. Always look at the height. Okay?
Max K.
So max GPE occurs at AE and I should add also and minimum KE, right? Correct. Why minimum KE at AE?
There's no speed.
There's no speed at AE, correct. So at A and E the speed is 0, so it's minimum KE. So the maximum KE C. At C, right? Why at C?
Oh yeah.
Why at C?
Because all the that's like minimum like GP
Highest-
converted to K.
Higher speed, right?
Yeah.
Okay.
Okay.
So in this one, what happens? From A to C, Jordan, you were saying what is converted to what? From
All
A
the
to
GP
C?
is converted to GP.
And then from C to E,
Converted back to GP.
converted to GP. Now this only is provided that what? What's the condition? What's the condition that all the GP become K, then after the K become GP?
Like some of the like kinetic store is not converted to heat store.
Okay, not considered the internal store surroundings. That means you don't care about air resistance, right? So all the energy, no energy loss to surroundings, easy way to say it. Or no energy transferred to the internal store, correct? That means you don't care about air resistance. But in real life, of course, there's air resistance. If not, what, the pendulum will just keep swinging forever and ever and ever.
So then is that why like from E you swing to B instead of A?
So eventually what happened? From A go to E and then after that slowly will decrease, right? Because slowly all the energy is lost to the surroundings. Okay? So you must know next week when we do the calculation that aspect how the energy is being converted from one form to another. But it's not so difficult. Okay? Okay?